So hi everybody, this is part 3 of our quarter 2 review. We'll be doing, I believe it's 7 problems today. So again, we left off talking about, point slope formula, slope intercept formula, our slope formula. And again, I have them on the screen today so you can see this is our point slope. Notice, what are we actually using? We're not creative in algebra, guys. We don't make fancy names for things. We have a point, or an x and a y coordinate, and a slope. That's what we plug in. All the orange parts stay the same. This is the slope-intercept formula. So slope and an intercept, a y-intercept. The only things we plug in here is the slope, which is m, and the y-intercept, which is b. The orange parts stay the same. And you have your slope formula again, y2 minus y1 divided by x2 minus x1. It tells you what the slope of the line is. Given a point and a slope, whether that point is a y-intercept or an x-intercept or just any random point, with one point and a slope, you can graph the line for that particular problem. Okay, so let's see what we're asking for today. First thing is, write an equation in point-slope form of the line that passes through the given points. Then write the equation of the line in slope-intercept form. Okay, so we look at this really carefully. It says, what is the point-slope form? So it's very easy. We have 2 points. We can calculate a slope using 2 points. So that's what we do. We have to take this equation here and figure out, we need to take this equation, plug in these 2 points. What's our m? Then we pick one of the 2 points at random and put it into this point slope formula. Then the second part wants us, well, now give your answer in slope intercept form. So all we do is we take our point slope formula, solve for y, and it transforms it into the slope intercept formula. So all these things we learned out of chapter 4 is all about, can we figure out what the slope is? Can you put it into one of the equations and get the other equation? Okay, let's start this and get going. First thing is we need m. M, our slope formula. Doesn't matter which one of these points we start with. We set our formula up. Grab the first one. The y goes on top, and its x goes right underneath it. Then we grab the next one. The y goes on top, and the x goes underneath it. We're ready to evaluate this particular function. So we have our thing, so we don't get messed up with the minus signs. We keep, change, change, keep, change, change. Now we're just dealing with addition. 8 plus a negative 1 is a 7. And then you should be able to easily go through and do negative 12 plus 9. So if you owe somebody $12 and you borrow $9 more, you have a negative. I didn't do that one right. Sorry. You have a negative 21. So a negative plus a negative is a bigger negative. Now, a lot of us, what we've been doing is we've been stopping. Someone's going to say stop and say, hey, here's my slope. I'm done. 7 over 21. That's not it yet. That would be wrong because it can be reduced. Notice multiplication is important in algebra because we use it to reduce things. We should know that there is a multiple of 7 that totals out 21. Okay, 7 goes into 7 one time, and 7 can go into negative 21 3 times. So here's our slope, negative 1/3 after we reduced. Great. Now we have this. We have 2 points. We need to put it in the slope, the point slope formula. There's minus signs in our formula, so we have to be careful. If we have the option of plugging in a point, I always choose the point that's all positive numbers because we don't have to do any extra work. Okay, there's no changing of signs. So it's very simple. We take our equation, y minus, well, what's the y coordinate? We look at our y coordinate. And the y-coordinate of our first point is a 1. So y minus 1 equals m. Well, we said m was negative 1/3. In parentheses, x minus, what was our x-coordinate? 9. Because it's positive, we don't have to mess with anything. We just plug it in. There is your point slope formula. Y minus 1 equals negative 1/3 times x minus 9. Now, we need to take this and translate it into slope-intercept. So what are we trying to solve for? We are trying to solve for this y right here. So let's do it. First thing we need to do is distribute this negative 1/3. So you distribute the negative 1/3 to each piece in our parentheses. Okay, so y minus 1 equals negative 1/3 x. And maybe you have to do, if you don't have a calculator, we'd have to do some side work. So you have negative 1. Well, a negative times a negative becomes a positive, so positive 9 over 3. And that reduces 9 divided by 3 equals 3. What's going on? I have my mouse that's deciding to do crazy things today. All right, so 3. Is y by itself yet? No. We have one more step to do. One more step to do here, and we have to solve our equation for y. Remember, we must keep it like a scale. What you do to one side of the equal sign, you have to do to the other. So we add 1 to both sides. Great. These cancel and leaves us y equals negative 1/3 x. So 3 plus 1 is 4. And here is our slope-intercept formula. So it's very easy. If you're given 2 points, you can calculate your slope. Take one of your 2 points and that slope you calculated, and you can plug it into your slope or your point slope formula. You need to turn it into slope-intercept, solve for y, and you're right there. So you can find all kinds of cool things. Here's our next one. Again, what did we say before? If you have a point, like they gave as a point, and you have a slope, like they gave as a slope, you can graph it. All you have to do is be able to put that point 5, 10, x coordinate's 5, y coordinate is 10. Put it on the graph, okay? So starting from the origin, we go over your horizontal movement, 5 units. And y is always a vertical movement, positive 10, so we go up 10. There's the point. 5, 10. Make it bigger so we can see. Perfect. Okay. Now what do? Well, we have to apply a slope. Remember, this is a negative slope. So Mr. Slope's eyes help to tell us what slopes look like. A negative slope should be going down. Rise over run. So you have negative 1. Negative 1 means you're going to go down 1 unit. Positive 3 would then mean you're going to go to the right 3 units. So down 1. And then to the right. 1, 2, 3. There's your second point. Down 1, over 1, 2, 3. And as you start to do this, you notice your line forms. And it is definitely a line that is sloping down. All right, that's how you graph. A point and a slope. Plot the point, apply the slope with the rise over run fashion. Rise over run. And in this case, since it was a negative function, we're not rising, we're sinking because negative numbers go down. We look at 19. 19's getting tricky. now they give us, notice, please notice, look how this is set up. This is in standard form. Do we remember that? Standard form. Standard form of an equation. Okay, standard form has all of our variables on the left and your constant on the right-hand side. They want us to figure out what is the x-intercept, what is the y-intercept of this graph. Because think, wherever this graph is going to be, just an example, if this graph crosses like this, it intersects the y-axis right here. It intersects the x-axis right here. There is an x and there is a y-intercept. So we can find it. This little thing here kind of tells us how. Well, how do we find the x-intercept? We can find the x-intercept when the y, this x-intercept here, when the y value is 0. It means you're not going up or down from where the origin originally was. How do you find the y-intercept? Well, there's no movement left or right from the origin. So when x is 0, you can find your y-intercept. So all we do to be able to find these is we plug in the appropriate 0. We want to find the x-intercept, plug in a 0 for y. You want to find the y-intercept, plug in a 0 for x. So you have to evaluate this particular function 2 times. The first time, we get rid of the y and we plug in a 0. And then you evaluate it. To find the next one, you're going to say, okay, now my x is a 0, so you use the exact same equation, remove the x and substitute the 0. And then you solve for your remaining variable. Okay, not very hard. Evaluate, move the constants, and then we divide to get our final answer. I know you guys can do that. Here we go again. Now, they've given us x and y intercepts. It says, draw the line given the intercepts. If the x-intercept is 2 and the y-intercept is 3. Okay? Just in case somebody has this exact form. Let's say our x-intercept would be 1 and a positive 3. Okay, so if the x-intercept equals 1 and the y-intercept equals 3. So the x-intercept on the x-axis, you go to positive 1 and you drop a dot. And the y-intercept, if it's 3, you come up to 3 on the y-axis and you drop a dot. And then you can connect these lines. What is it? Down 3 over 1. 1, 2, 3 over 1. And of course, Math Excel will connect those lines for you, but you see it forms a nice line. That's it. X-intercept, drop a dot on the x-axis. Y-intercept, drop a dot on the y-axis. Connect the 2 points, especially if they give it to you guys. Here is some special graphs, and I remember graphs were so torturous for us. We had to do the lesson twice because people didn't want to do their homework the first time and just do it. So we have lines that have the positive and negative slope. This is Mr. Slope's eyes. These are the majority of the lines that we deal with will look like his eyes, either a positive slope or a negative slope. Then we have the 2 special cases. What happens when we have the line y equals, or we have a line x equals? Those are special lines. And if you can remember Mr. Slope's face, you'll always get these questions correct. Okay, so you have his face. His nose is a straight line up and down. It's a vertical line. It has an undefined slope. That's what the little U in the nose is supposed to tell you. And what comes out of noses? A booger, a little x comes out. So anytime you have an equation that just says x equals a number, it's a vertical line that crosses the x-axis at whatever that number is. What about his mouth? His mouth is another special thing on here. It just doesn't happen. We didn't put it there to make it anatomically correct. It has a meaning. His mouth is a horizontal line. And notice there are little zeros at the end of his mouth because a horizontal line has a slope of 0. It's like your floor. Hopefully the floor of your house is flat, and if you put a ball on it, it doesn't roll around. If it rolls, your floor is not a horizontal line and it has a slope. So the mouth, think of a Y, kind of looks like a little tongue sort of coming out of the mouth. So anytime you have an equation that says y equals a number, like our example here, y equals 7, notice there's no x. So this should tell you right away, hey, that's a part of Mr. Slope's face. That's his tongue. His tongue has a slope of 0. It's a horizontal line. So it is a line that crosses the y-axis at 7. And if you go through every single time, the slope is 0. For every value of x, it's always going to be 7. So every single coordinate in this entire line is -2, 7, -3, 7, 1, 7, 0, 7, 25,000 billion 7. So, and it goes on forever and ever in both directions. Of course, Math Excel would connect the line for you. It's a little bit harder using a mouse on this. And imagine that. If we just did a line, if I just made you graph a line that was y equals, of course, I'm going to make you graph a line that's x equals. So let's graph, I'll leave this one for you. Let's graph x equals -10. So it's going to be like his nose, like Mr. Slope's nose. Undefined line, it is straight up and down, so it's going to cross that x-axis at -10. And that means no matter what value of y that we have, it's always going to be, your x-coordinate will always be -10. So it's -10, 1, -10, 2, -10, 4, -10, -6. Notice, if we were to try to do a vertical line test on this, we would fail it miserably. It would, if you drew a vertical line over this, which is exactly what you end up doing anyways by graphing it, this is not a function. That's why we have a weird undefined slope. It's not a function. There's not a constant rate of change here. Every single x-coordinate is stacked on top of each other. So again, that's why we have Mr. Slope, and Mr. Slope has these special cases in his face. His mouth and his nose tell us these special little parts when it comes to graphing linear equations. Not all linear equations are a function. All of them are a function except for x equals, because it is a vertical line, so it would fail your vertical line test. All right. 23. We're going to look down here at 23, and it says write the equation in standard form using integers. So remember, we have a point slope formula. That's what they give us. And we talked about standard form up above a few questions where it's ax plus bx equals c. Actually, this is supposed to be a y. My apologies. And what we have is we have all of our variables on the left hand side, and the constant is on the right hand side. So when we do this, all we have to do is move. We're kind of solving, but not really, because we're not actually solving for a variable. We're just using all the rules we have for solving equations to move our variables all to the left hand side and make sure any constants we have are going to be on the right hand side of that equal sign. So the first thing we do when we look at this is we have 2/3. we have to distribute 2/3 to each piece. So we end up with a y plus 2 equals 2/3 x. And now side work, we have to multiply 2/3 times 5. So that becomes what? 2 times 5 is 10. And technically this is like a 5/1. So 3 times 1 is 3. Does 10/3 reduce at all? No, it doesn't. It's not pretty looking right now, but you'll see. Maybe it'll simplify later on. All right. Is all of our x's in the right place? Is all of our constants in the right place? No, it's not. So we still have to do another step. We need to move this constant over here, and we need to subtract this x over to that side. Okay, so let's do it. We need to subtract 2/3 x. So take away 2/3 x. Y minus 2/3 x equals, here's some side work. We have to now subtract 2 from both of these. So you have 10/3 minus 2. Remember, anytime we subtract fractions, they have to have the same denominator. Right now, this one here has a denominator of 3. This one here doesn't. So to make it have a 3, we have to do a little bit of side work. We might have to multiply this by 3/3. Technically, 3/3 is 1, so we're not changing its value. We're just algebraically manipulating that fraction into a larger version of itself. Okay, so 2 times 3 is 6. And 1 times 3 is 3. So now we have 10/3 minus 6/3. Well, 10 minus 6 is 4. And then you have 3 minus 3. Well, that doesn't matter because we don't deal with that. We just have to keep the same denominator. So we have the fraction 4/3. Is 4/3 reduced? Yes. It can't get any smaller. And you're done. You've now put this into standard form. You have all of your variables there. Now the only sometimes the only thing that they don't like is, and it depends on your textbook, is that sometimes they don't want you to have a fraction here. Okay, I believe our textbook will leave it alone and say, fine, great, you're good, you've moved it. Some only want you to have integers. So actually this one may be it, because if you see it says using integers. So we need an integer here, not a fraction. So how would we get rid of the 3's? If we were to take this entire problem and we multiply the whole thing times 3, like we're going to distribute a 3 to each individual piece. Look, so 3 times y would equal a 3y. 3 times negative 2/3, well, the 3's would cancel out the denominator, so you would have a minus 2x. And then the 3 would also cancel the denominator here, which would thus give you a 4. So then here is definitely a more proper version of standard form, where you have all of your coefficients are integers. We look at 24, it says write an equation in slope-intercept form. All right, so we just talked about it earlier up above, your slope-intercept form. Okay, what do we need to be able to put it into that form? We need a slope and we need a point. So here's our point, but they didn't give us m. Yes, they did. I promise you they did. Look, y equals mx plus b. They're having you pluck the slope out of your slope-intercept formula. This is how they'll trick you on an EOC test. They give you something, you're assuming they're just going to give you slope. Well, what they do is they give you another equation and they're testing you. Do you know what the pieces of that equation are? I hope so. So now you have your point, you have your slope, and you can stick it into this equation. Notice what's weird about our points they gave us. Notice I'm putting parentheses here for a reason. We have to be careful. Do you see it? I know I see it. We have -3, -2. So if we are looking at that -3, -2, we have to be careful. We have to be very, very careful. I'm changing colors so we can see what's going on. First, the easy part, our slope. This is m right here. Plug our m in, -3. Our y coordinate, which goes here, is -2. Yeah, you see it now? Look, we have a minus and negative popping in. X coordinate, -3. So you have to be careful. You can't leave it like this. While we do have one set of parentheses in our original formula, which is fine to leave, you can't keep these second sets of parentheses here. You need to simplify this. So one more step, y. A negative times a negative, keep, change, becomes +2, equals -3, parenthesis, x, keep, change, +3. And now there is the nice final answer. It's sitting here in proper form. There's no extra sets of parentheses. You properly distributed this hidden -1, and you're good to go. This will be the last question we do for this one here. Notice that they have something set up here. They want us to determine whether the given lines are parallel, perpendicular, or neither. In order to do that, you have to be able to look at something. You have to be able to look at it and say, hey, I know that parallel lines, two parallel lines like the equal sign, okay, they run side by side forever. They never touch. So in order for them to never touch, they have to have the same slope. If this is like the equal sign, well, this is like Mr. Slope's mouth. So this one has a slope of 0, and this one has a slope of 0. So parallel lines always have the same slope. Perpendicular lines run into each other like this, like a T. So if one line is 2, okay, if you have one line being like 2, and the other line is going to be the opposite reciprocal. So opposite means change the sign. So we change the sign. And then the reciprocal means you flip it upside down. So if this is a positive, just a 2, we put 1/2. So here's the difference between these represent two different perpendicular slopes, 2 and -1/2. Opposite, sign change, reciprocal, flip it over. If it's neither of those, if you have two totally random lines, what's going to happen is these two lines at some point are going to intersect. Okay, so therefore when they intersect, they're not intersecting at a right angle like a perpendicular line, this little nice right angle. They're intersecting at a skewed angle of some sort. All right, so take a look at this one. It's two lines, and this is a special case. I use this example here for a reason. Y equals 3, y equals 8. Anytime you have a line that says y equals and a number, it's Mr. Slope's mouth. So the slope of this line is 0. The slope of that line is 0. Are the two slopes the same? They are, so it would definitely be parallel lines. All right, get busy, guys. I'm sorry, I know that this one was just a little bit longer, but there was a lot going on with a lot of different formulas. And again, really playing with those particular formulas and making you transpose from one formula to the next. Use the slope formula. Use a point and a slope. Plug it in the point slope. Solve it for y. You get slope intercept. Get busy. Get started on your work. All right.